Alright, hello, this is Ian Dwyer, and I'm recording for assignment 1 in IoT. I'm going to run through my code real quick, or my codes, multiple, and then I will be following up with a video of the functionality of the equipment. So first, we're going to go into the Wi-Fi chip that was flashed. It was the ESP6822 that is used for this with an Arduino and a motion sensor. This is a motion sensing project where when you walk across the field, it will then turn on a speaker remotely. So for the Wi-Fi chip flashing, we have this. This is taken from ThingSpeak example and modified. Since that one was meant to push strings through, it was then modified to be able to push integers. You can see here where I'm highlighting. This is the original data that was pushing a string through. I cleared that out and just put this through to push it over to the channel, and it just accumulates data there. So it's fairly straightforward. Next is the actual Arduino code for gathering sensor data. And what we have here is we have our receive transmit pins being declared, and also a few other functionality pins. This is the input for the sensor. This is the output for our test LED to say whether it's sensing or not, which helps us to be able to know the trigger points for the motion sensor. The per state is going to be the motion sensor state. We're automatically setting it to low. Oh, it looks like we have it twice in here. We don't actually use this version. So next we have our validation. This is going to be the variable that is going to tell us whether we are receiving a signal or not. This is what's going to flip when the sensor sees us. And then these are times to be able to actually define the amount of time in which it's off for, since delays prevent real-time updates. Using the delay function prevents real-time updates to ThingSpeak, and then also therefore messing up the time with the speaker triggers. So we're avoiding the delays using on time and current time checks using the millis throughout here. And so first we have a validation digital read that's going to say whether it's high or not. If it is high, we are then going to write to our pin to run high for our LED. This LED is going to, just like I said, be the indicator for whether there's anything going on. The my serial write is for being able to write the data over through the Wi-Fi chip, as we had previously shown that we'd flashed. And then here's the on time within the if loop of when it triggers. And what happens is then the high state then is enabled, since this is now high, to say that the sensor is reading something, and this is really more of just a trigger for our following conditional. After that, before I get to that, we have our digital write. This is going to turn the LED off immediately, so it's not constantly indicating that it's sensing something when it's not. And then here's the current time, where it's checking the current time and it's backing up against the point in which it was turned on. And as you can see here, it triggers every single, this on time restarts every single time it senses anything. And this prevents a cutoff and having to restart again, so that it can keep re-triggering and it doesn't short cycle our speakers. Then finally, we have it to write the validation when it is 0 and it's above 180 seconds. It writes the validation data of or the value of the data, the value of the data to be 0 through the Wi-Fi chip, and then it sets the state to low so that it can realize these functions. Now next, I believe it is important to go over to the Python code. So on the receiving end, we have our actuation is a speaker, The speaker is then triggered through Python and using a Raspberry Pi and using the GPIO header through there. Due to the Raspberry Pi only having a 3.3 volt output for its digital out pins, we had to do low side switching for a 5 volt for the 5 volt speakers to be able to get those to run. Just as some reference. So in here, this is fairly straightforward request. This is going to be for the ThinkSpeak. Our Pi GPIO is going to be able to do the Raspberry Pi, and or is what we control it with what we control the GPIO header with, and then the rest are just adjunct support library data. So pretty much we just have, while it's true, we're going to append all the data, and it is going to check the time. The time check is just strictly for plotting, so I can plot on this end second by second to see how the data appears. And finally, I'm going to show you a video of its functionality. Alright, so for the hardware part and the functionality part of this video, we can see, so the breadboard actually, this is the Raspberry Pi receiving the signal from ThinkSpeak. In this setup, only the right half of the breadboard and the Raspberry Pi is actually in use. And we can see that we did low side triggering with the transistor over in that corner, and diode to be able to get the speakers to work. And then, so this is all hooked in over there, and then we have, and the audio is coming through the tablet and is constantly running. The only thing that's actually happening is the speakers are switching on because we ended up splicing the voltage cable, or the power cable. So then over here we have the hardware for the sensor, and the sensor will then trigger the audio. As we can see, there's a light that triggers it. There we go. Every time it senses anything, it sends over to ThinkSpeak. And then, let's see, it's taking a minute to update. There we go. So then it triggers over here. And then if we go over to ThinkSpeak, we can see now that this, first off, is showing that it's getting a 1 for the signal. And for ThinkSpeak, you can see that it's live updating here as I'm standing in front of the sensor. It's been on most of the time. It turned off for a minute before I shot the video, and now it is back on again. You can see it's building data right there.